course of this year, I've been working on a project to directly capture carbon dioxide out of the air. Now, over the course of this project, I've made many short explanatory videos that I've put together here. Now, this is just the first phase of our project, where we only are here to prove that the chemistry is sound, that it is possible to scale our project up in future phases.
Currently doing an experiment to try and capture carbon dioxide out of the air using this solution of sodium hydroxide. Now, how we're doing that, we're bubbling the air through the sodium hydroxide solution using this fish tank bubbler here. And what should happen is that the carbon dioxide in the air should react with the sodium hydroxide solution should slowly convert it to a sodium carbonate solution. Now, we can see on our monitor that the amount of carbon dioxide coming out of the air is pretty low compared to the amount of carbon dioxide in the air. As you can see, if I take this out, now it's just sampling the air around us, the carbon dioxide levels should go back up, as you may see in a moment. Yeah, they're starting to go back up a little bit. But now, if we put the sampler back into near the solution in the flask, we should see that the carbon dioxide levels will drop down to about close to zero, as you may see in a moment. As you can see, the carbon dioxide levels are dropping. And right now we're sampling the air in this flask, or coming out of the solution. That must mean that this solution is capturing the carbon dioxide out of the air. After bubbling air through our sodium hydroxide solution and converting our sodium hydroxide to a sodium carbonate solution, we added calcium oxide, and that gave us a calcium carbonate precipitate at the bottom of this container. Now what we're going to do, we're going to pour off most of the liquid part in this beaker, which should be sodium hydroxide. Then we're going to vacuum filtrate whatever's left to get most of the water out. We're going to dry it and then heat it up to 840 degrees C to get the carbon dioxide out. Thanks to vacuum filtration, we got almost all the liquid out of our calcium carbonate precipitate. And now we're just left with this watery paste. So what we're doing now, we're taking that calcium carbonate paste and we're heating it up to try and drive off the last of the liquid in our drying oven. And we're hoping to just be left with a thick powder. So we fully dried out the calcium carbonate powder, and now the next step is to build an electric heating oven which will heat this powder up to 840 degrees C, which will drive off the CO2, which we can capture. Now, we will have to take a little bit of a break from the chemistry just while we're building the electric heating oven. We built an electric heating oven, and what we can do is we are going to suck the CO2 from our electric heating oven through this system where we can capture and monitor it. Now, because the air coming out of this electric heating oven is going to be very hot, we had to build a cooling coil, which is going to be sitting in a bath of ice water. Now, in the future, in case we want to capture the CO2, we can attach a compressor here. Also, our monitor is going to be hooked up here. Now, we don't know if the carbon dioxide coming out of the electric heating oven is going to be very high pressure and is able to flow through the system by itself, or is very low pressure. And in that case, we may need to hook up a small vacuum pump right here. Just in case the pressure is very high, we have an emergency release valve right here. We are currently doing our first test run of our experiment, where we are heating up our calcium carbonate to 840 degrees C, and then we are running it through an ice bath to cool it down, and then we are going to monitor it on our carbon dioxide monitor here once it reaches 840 degrees C. Before we heat up our calcium carbonate to get real measurements, we're first just trying to get a control, and we're doing that by just measuring the ambient air around us. And we're currently reading around 1,200 parts per million, which is a typical indoor carbon dioxide level. We are now in the final stage of our carbon dioxide experiment, and we are finally heating up
all of our calcium carbonate to the 840 degrees necessary to drive off the CO2. And now we know for certain that we are driving off CO2 because you can see on the gas level that we have around 5% gas compared to the fraction of a percent gas in normal ambient air. As we've let the process run, we got up to a maximum of 8% carbon dioxide. So in the long run, we want to add a compressor into our system so we can actually capture the CO2 we're heating off. And we want to go through the entire process and try and find ways we can optimize.